Okay, we came to the recording a little bit late. But we're talking about somebody's beaver baby and the chances that when this female beaver baby produces eggs, they'll have a big T or a little t, and somebody's baby beaver boy and the chances that any sperm that he produces will have a big T or a little t. So now we're going to talk about heterozygous and homozygous. If we go back to both of those beaver babies, both of them have two different alleles for this trait. They are heterozygous, okay, for that trait. So they have two different alleles for the trait. If you are heterozygous genotype, and heterozygous, homozygous only refer to genotype, what's your phenotype going to be? Nope. If you are heterozygous, your genotype is always, always, always going to be controlled by this dominant gene. So heterozygous is a genotype. Heterozygous genotypes always show the dominant allele. They always show the dominant allele. Okay, so if hetero means different and heterozygous means you have two different alleles, what does homo mean? Same. So an individual that has got a homozygous genotype. Well, for this characteristic we're looking at, tail length, give me one of the possibilities for a homozygous genotype. I heard big T, big T. What's the other one? Little t, little t. Those are, so these have the same, whoops, let me rewrite that. So a homozygous individual has the same two alleles for a trait. And homozygous individuals' phenotype could be either the dominant, so we'll say dominant phenotype, and this one is going to show what? Okay, so that big T is going to show the dominant phenotype, the little t is going to show the recessive phenotype. Okay. Questions or comments? So, okay, you're all familiar with that is the symbol for female biologically, and this is the symbol for male biologically. Okay, so we did a little bit of Punnett square stuff before the OGTs, but we're going to revisit that. Okay, so traditionally we put the mother's contribution on top, the maternal contribution. What did maternal mean? You looked this one up the other day. So each of these columns here represents basically, or each of these boxes represents what could be in a gamete. And each of these squares ends up representing the possible genotype of an offspring. So if this beaver female and this beaver male reproduce, all we do is draw these down, and you've done these before. This is not rocket science. And we typically switch these around so that we have them capital letter first, because we want that capital letter first. Okay. So we now have the possible genotypes for their offspring. Those are the only four possibilities for genotypes for their offspring. What percentage of them are homozygous dominant? So I'm going to list these four. Well, I'm going to do a couple things here. Hold on. Okay. What percentage of them are homozygous dominant? How many? 25. Yeah, 1 out of 4. So 25% are homozygous for the dominant trait. What percentage of them are homozygous recessive? What percentage of them are heterozygous? 50%. So these 2 out of 4, or 50% of them, are heterozygous. Those are our genotype ratios, and they're very often expressed as, we say it's a 1 to 2 to 1 ratio. Okay? Not ration, ratio. I got carried away. So we say that for a heterozygous cross, why is it called a heterozygous cross? What were the parents? They were both heterozygous. They were both heterozygous. This is how 2 dark-haired parents have a blonde kid. And actually hair color is more complicated than that. But both of these parents would have shown, so let's talk about phenotypes. We'll shrink the genome. So what were the phenotypes of the parents? Mom was long tail or short tail? Long tail. Mom is heterozygous. Heterozygous individuals exhibit the dominant characteristics. So mom was a long tail beaver. What about dad? Dad was also a long tail. They were both heterozygous. So you have 2 long tail beavers. And you say, well, what are their offspring going to look like? Well, how many of their offspring are actually going to have a long tail? Okay. Let me pick one more color I haven't used yet. Okay. Is this homozygous dominant individual going to have a long tail? Yes, that's 1. Are these heterozygous individuals going to have long tails? Yes. So 3 of their 4 offspring are going to have long tails. 75% of their offspring are going to have long tails. 3 out of 4. But what percentage of their offspring are going to have a short tail? Yeah. That last quarter, that last little one will be the little oddball in its family. And this little person right here, this little beaver, is going to have a short tail. So the phenotypic ratio for a heterozygous cross is 3 to 1. Okay? So we have heterozygous parents. What you are going to start working on, we'll get you started, and then you'll end up finishing on Monday. You will find, so there will be 2 things that you're working on, because girls, some of you will, those of you who have beaver daughters, you will not all have a mate immediately. You might have to wait for a boy to be available. So that definitions and vocabulary page, you're going to go back through that and start doing your after definitions now that we've talked about some of these concepts. So for each trait that you have, here's what you're going to do. You probably need more structure, huh? You want me to develop a worksheet so it shows you exactly what you're going to do? Okay, I'll have a worksheet for you when you walk in on Monday. And on Monday, you're going to do crosses for each characteristic for your beaver babies. Okay? That's where we'll wrap it up for today.